live and yeah. Oh yeah, we're live. So we actually have people joining in on LinkedIn and also on YouTube, and we also have people on Zoom. And yeah, so people joining us on time, thank you so much for being on time. And I'm very, very glad and happy to have an audience, which is very exciting to learn something on weekend. And we're going to wait 1 to 2 minutes, guys, and we'll not take more of your time. So we'll wait for everyone to join in. Until then, please have an icebreaker in the chat. Let us know what's your name, which part of the country you're from, which company you're working for, and what's something that you're excited for this webinar today. So yeah. We have an amazing panel today. So we're very excited to have something to discuss in a very advanced topic this time. And we are very excited. So people watching us on LinkedIn and YouTube, if you want to share the live link with your friends or your colleagues at the last moment. So we are actually live on a Recro's LinkedIn and YouTube channel. So you can share the live link directly. If you have not received any notifications from Zoom because we started the promotion since 2 weeks, you can watch us live on LinkedIn and YouTube. I guess I think we can start with the webinar today because we have enough people watching us live on LinkedIn. Yeah. So yeah, I think we can get started. We're not going to make people wait who are on time. Okay, so hello and welcome everyone. Hope you're keeping well and staying safe. This is Hafsa Anjum and I'm working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as Curefit, Udan, Swiggy, Dunzo, etc. So welcome to Recro Talks again. And today we are doing an amazing and a very exclusive webinar on automating GraphQL schema and code generation using NestJS and ReactJS. And our guest speaker for today is none other than Parminder Singh. He is a front-end engineer at Amazon. He's a self-taught UI, UX developer and designer. He's rich in creating. He has experience in he has an experience of using the modern web technology and trends, and he works with the front-end technologies mostly, and front-end evolved from the early jQuery days to Angular 1 and backbone of React and ES6. So he also lives in Cambridge right now. So if anyone is from Cambridge and watching us, drop hi in the chat and we'll be happy to see people from there. And thank you so much, Parminder, for joining us. And we're very happy to have you today, and all the love from the audience. And thank you so much for joining us once again.
Right. Thanks, Hafsa, for the introduction. I'm gonna share the screen.
Yeah.
Oh, it says, yeah.
Yeah. So before we start with the presentation, Parminder, there are a few announcements I want to make. So you can, and that's for the audience. So you can post your questions in the question section and we will take up the last 15 minutes of the session, and we'll also take up the questions between the presentation. So please ensure that you don't shy away from asking any questions. And people who are watching us on LinkedIn and YouTube, we will be taking the questions from the live chat. So please ensure that you are asking any questions that you're actually doubtful about, or you need some help around that, and I'll make sure that I'll get that in front of the speaker. And we'll be rolling out the poll in between. So please do answer them and keep your notepad handy. And whatever you're learning from today's session, we would love to see it on your LinkedIn post. And that would really help us to, get better speakers like Parminder. And we would love to see your learnings and takeaways at the end of the day. Right. And over to you, Parminder. I think we can get started. Let me know if you're able to share your screen.
Yeah. Also, there's a note in the chat. It says chat is disabled. Is that on purpose?
Let me have a look. Okay, guys, can you just chat right now and let me know if you guys are able to say hi? Yeah. Let me know if the chat is disabled now.
Okay, yeah.
Yep.
Working for me now. Cool.
Yes, I think we can get started.
Yeah, I hope my screen is visible to everyone. Hi, everyone. I'm Parminder Singh from, right now, streaming from Cambridge, UK, and I'm associated with Amazon Web Services at the moment. I work with the S3 Console team. So, yeah, I'm a front-end engineer here, and I've been working as a front-end engineer for past 9.5 years. So as Hafsa mentioned, I worked on a multitude of frameworks and libraries in front-end domain, and not only web, but also I worked in native. I worked on React Native, and right now I'm very excited about Flutter as well. So I develop web and mobile apps. Web interests me a lot because of its inclusivity across various platforms. And so at my last company, when I was working on React Native, so I was getting this mundane problem about, how we can sync the backend APIs to the front end in an easy way, and how I can enhance my front end experience, developer experience, and take it to the next level. So this presentation or this demonstration is going to be about how you can advance your development workflow and make it more error-proof by introducing GraphQL over the REST APIs, which you might have been using so far. And I stumbled upon this really nice framework while I was researching for a good one. It's called NestJS, and I'm in love with it. And it brings back all the good memories I had in Angular 2. So it works on the same kind of architecture using the modular approach and everything like that. So I love that about Angular, and now I can see all the goodness in NestJS as a backend framework. So that eases up a lot of things. And then we'll see how we can bind it together on the front end side using React. And not only using React, but also generating code for React. So we'll be generating the hooks on the fly, so you wouldn't have to do anything. So let me just demonstrate of what we'll be discussing about. So this is the end result of the thing that we'll be discussing. So it's nothing but a CRUD portal wherein you can create a post, let's say a test post, and it will get added. And then those posts will have some sort of comments, there's a one-to-many relationship here, comment 1, and then you can delete a post as well. So as you can see, it's a very common application. Okay, there's some last minute error, sorry about that. But yeah, this is what we'll be discussing about using NestJS in the backend and React in the front end, of course. And of course, using GraphQL as the API layer in between. So yeah, let's just move forward. So we'll discuss about what are CRUD apps and why do you need GraphQL in the first place? What's wrong with REST APIs at the moment? And what are the pain points that GraphQL solves? We'll explore that with some practical examples. And then we'll see how we can build the GraphQL schema using NestJS itself. You don't have to write GraphQL by yourself. It'll get auto-generated by writing the NestJS classes themselves. You just have to use some decorators and it'll get translated, auto-transpiled to a generated schema. And then we'll see how we can use that schema on the front end to generate those queries and mutation hooks and bind that in a UI format on your React components. So that will be the overall agenda of this presentation. Let's move on with understanding what are CRUD apps. So I assume most of you have worked with CRUD applications. CRUD is nothing but it stands for create, read, update, delete. So what it means is these are the 4 basic operations in any sort of front-end app you can see. Most of the front-end apps, I mean, if we are talking about the gaming apps, then that might not be true. It's mostly that also is true. There are some kind of CRUD apps, CRUD operations over there. But nevertheless, these are the 3 operations. So let's look at an example. So look at this typical CRUD app, which says, which is a dashboard for apparent employee management. And we can add an employee. Now, adding an employee is a create operation. So that stands for the C inside the CRUD. And then the read operation is the list of employees which have already been added that I can see here. And then update operation represents this edit button here. And then the delete operation is the delete employee itself. So you can see, you can relate this to any of your applications that you might be making most of the time. I mean, yes, if you're making some sort of a read-only application like a portfolio, that is read heavy. But on the other hand, if you're making a dashboard or any sort of app where user interaction and data saving is necessary, so that will come under the create and of course read, because you're creating the data and you're also reading the data. Okay, I believe that's enough introduction on CRUD apps. Now let's move on to the experience, or what's the major pain point in CRUD apps. So it is, as I said, very common to make this kind of apps in general. So that's what we are trying to solve here. What are the challenges that we face? So first is that we have to fetch really large bodies of responses, and that wastes a lot of the precious bandwidth. So consider this example of a weather app that I made in Swift, and I'm using the Open Weather API here, and this is the response that I get from the backend, from the API. Now, as you can see, I just need the temperature, I need the humidity and pressure, and list of the future weather events happening in the coming week. But you see, I get a lot of other noise here. So I'm getting this irrelevant information like the sunrise and the sunset, and a lot of other fields like dew point and UVI, which I don't need. Now, consider this in a very huge app, wherein, for example, if you consider an app like Flipkart, so even few kilobytes over there would make a lot of difference. So in order to save that, so the APIs, there should be a way to craft your APIs to fit the needs of a UI. And it shouldn't be like that you'll be bothering the backend people with, telling them, okay, just don't give me this, give me that, give me this in this particular format. I think that's a major pain point I have personally faced, working as a front-end engineer and coaxing backend engineers to please provide a given thing in this manner. So the bottom line is that one size doesn't fit all. So for example, the backend people, they would create a generic API. So when Open Weather API people created this, they didn't know about the front-end outlet you're going to make out of it, right? So I might need this information, but another person making an app might need information heavy on UV index, or let's say they want to show the sunrise and sunset. So that's what I mean by one size doesn't fit all. So what is the solution? We can't ask Open Weather API to change their API just because my app wants it in a certain format, right? So from backend, they have provided us with a generic API. They have given us with all the information they have in their systems, and we want to consume it in the way we want. So that's when GraphQL helps us. So this is, again, the same example. And if there was a way to tell the API that, okay, these are the fields that I want out of this particular structure, I just want these 4 fields out of all the noise we are getting. So that's a very good way to solve this problem. Now, this is exactly where GraphQL helps us, and it helps us this problem of data pruning. So we can tailor the data according to our needs, and we can tell this is what we want. And our front end would define the structure of your API response by specifying the fields. So however the front end we want. So it could be very well possible that this screen has this information, and there could be another screen in the same app which might require other information. So we can create like 2 different queries for the same API, and we'll get a subset of the data that we need exactly. And backend doesn't need to accommodate changes. Backend just need to create a generic API, and we will tell backend what we need out of it. So that's the first and biggest benefit of using GraphQL and the problem that it solves. And the second problem that it solves is eager loading. Now, how many times we have come up in a situation wherein, for example, there's a user, and let's say we want to design a screen on the front end which says, give me all the albums of this user. And from that album, I just need a cover picture to show on the list page. And then when the person clicks on an album, I want to show all of the photos in it. So it'll be very difficult if our backend API doesn't accommodate this need. So for example, I believe if you were using it in the REST format, it would be like, you'll get the albums along with the photos of the album. So you'll end up loading the photo URLs as well, along with the album itself. So that'll be a huge waste. Imagine an album with hundreds of photos, and there are like 10 or 20 albums. So that'll be too much of a data wastage. So we want to tell the backend that only load all of the photos only when the person goes to a detailed view of an album page, right? So that's called eager loading. Lazy loading. So we want to open up the albums, open up the photos only when the person navigates there. And on-demand loading of so that's a very good example of relational database, right? So one user can have many albums, and one album can have many photos. So GraphQL helps us, have these things in place with it. So it'll be, yes, it's achievable with REST endpoints, but it'll be too much work and it'll be a little messy. You have to send a certain flag in the API itself, telling them, okay, don't eager equal to true or eager equal to false like that. So, but GraphQL helps us do this in a very neat and a robust manner. We'll see that in a moment. But yeah, these are the 2 things that GraphQL helps us. Please hit any questions if you might have in the chat so far. So GraphQL, somebody's asking GraphQL, what is GraphQL? So it's an API standard through which we can create APIs. We'll see that in a moment, how to do that. So it's basically, you can see it as a replacement of REST APIs, like you use the get, post, put, delete APIs, HTTP APIs. So there's a single endpoint which we hit, and we get all the results out of it. Probably I can demonstrate that while we are receiving any questions from the chat. So
I think we have one question. Yeah, is
yes.
NestJS alternative for Node? What is the question?
Is NestJS what?
Is NestJS alternative for Node? Like, is it an alternative for Node?
Alternative. No. NestJS is nothing but a framework. It's nothing but a framework built on top of Express and built on top of Node.js, and you can configure it to have to use either Express.js or this another Fastify.js. Why is NestJS popular these days? Because it's a very full-fledged framework. It's not a library, so it is very opinionated in terms of devising the APIs. So you can, and also in terms of code generation that we're just going to see in a moment. So it's a framework. It's not an alternative. It's built on top of Node.js, right? Okay. So I was going to show the APIs here. So this is my application. And you can see, so I'm hitting an API endpoint to get all the results for the posts that I've created in the past. So there's no API that says /posts. There's only one API which says /GraphQL. And it's a post endpoint as opposed to a get endpoint. And we are sending something in the body of that API post endpoint, and which says, get me the results for get post operation. And out of those get post operation, get me the title of the post and the comments which are there. And out of those comments, give me the title and the IDs of that those comments as well. So this is the difference between a normal REST API versus a GraphQL API. So there's a single endpoint, but we configure the single endpoint by passing it some payload. There's another question, NestJS is best or Node.js? So again, as I said, it's not NestJS versus Node.js. NestJS is built on top of Node.js. So it basically is a framework. It helps you do a lot of things which are baked into the framework itself, so that you save a lot of time in not doing those things by yourself. So yes, it's pretty much like, yeah, the difference between ReactJS versus JS. So JS is a language or the base thing, and ReactJS is built on top of it. Yeah.
We do have a question, Param.
Yeah.
That is the process. What is the process of setting up the NestJS server with the GraphQL module for a ReactJS project? So, yeah.
Yes. So we can go through a guide here in the documentation of NestJS. They have very good documentation. But going into that will take a lot of time in this presentation. But we'll definitely learn on how to, it's nothing but a bunch of commands. So this is how you install the NestJS CLI, pretty much like React, create React app CLI. And then it's simply very easy, basically, to start it. You don't have to do anything. You just have to run these two commands and it'll set up everything for you. All you have to do is configure things like your database and, you know, the username and etc. It's highly configurable, right? So yeah, that was about GraphQL. But let me also show you how you can explore the GraphQL. Let me show you the code examples. Are you using a Polo server? Yes, I'm using a Polo server. It's inbuilt in it. So this is the GitHub repository. I have attached that in the link as well. I'll share everything after this presentation, so don't worry about it. So this is how I hope the screen is visible. This is how my folder structure looks like. So it's an isomorphic app, which means everything is there in one repository. You can choose to have different repository, of course, but that's not something we want to discuss here. So there's a server folder, which has my NestJS app, and there's a client folder, which has my ReactJS app. So let's look at the server folder. I've generated this using the same command that's listed here in the NestJS documentation. And this will create this sort of structure for you. And all you have to do is configure some certain things inside the main file. So in the main file, it's loading an app module, and you can configure the port that you want your app to listen to. And then inside here, this is where you configure your database, because we are talking about a CRUD application and database is paramount here. So I'm using Postgres. You can use MySQL. You can use any other kind of database. It's highly configurable, as I mentioned. And configure the host names. So everything, ideally, it should come from an environment in a production app. Please don't do that in your production apps for sure. But this is just for the demonstration purpose. And then I'm using a username, which I have as param. There's no password. Again, don't do that in production, of course. And I have created a little database called as demo. So let me show you it in Postigo. It's an application which helps you explore the database, pretty much like, what was that app? SQLite that you have. So I've created these databases, and this is the database that we're looking for. It has two tables, post and comment. Now, please mind that I haven't created these databases by myself. I haven't, what I mean by that is I haven't gone into the SQL command line and created them by myself. I've created the JavaScript code first for it, and they automatically got translated to these things. So that's the beauty of using a framework like NestJS. So it's a code first approach. So you code the things that you want, and it'll automatically get translated into the database. So all you have to do is configure these things, and it's through the virtue of this another library called as typeorm. So I'll show you how I created the tables of post and comment. So let's look at the post table. So this is the post folder, and again, you can generate all of this using a certain command, ng nest generate resource, and it'll generate all the files for you. And then what you have to do is inside the entities. So this is what I mean. So you need to just create a class of whatever table you want to name your whatever table name you want to have, matching that, and then you can specify the certain characteristics for a certain column. So these are all the columns for the table that you're going to create. So I want an ID, and which has a auto-generated primary ID. It's a primary key, and then a column name title, and then also I've added a relation between another table called as comment. So comment table is also created the same way. If you look at the comment entity, there's a primary key field name as ID, and there's a title, and then also a join clause here with a post. So it's a one-to-many relationship. So here it's many to one, and there's one-to-many. So it's very easy to create this, and all you have to do is start your server and nothing else. It'll generate these commands for you instantly. And if you look at the structure of this table, it says, okay, there's an ID, which is primary key, and it's a UUID auto-generate one. And then there's a title and there's a post ID. So you see, I didn't create a column named post ID, but I just set some decorators and it handled everything by itself. So that's the first step, right? So you created the database schema by just writing a class, which will not only be used for TypeScript purposes, but also for GraphQL, as we'll see in a moment. So this is my post and this is my comment. And that's how it created it. And the contents, of course, you can see here. Now, taking it to the next level, we can also generate a GraphQL schema for this. So there's a file which I have here. I haven't created this file by myself. It got created, I think this file was automatically generated, do not modify, because if you modify it, it'll automatically get generated again and it'll be of no use. So how will this get generated? In the same way. So in addition of adding the database related decorators, I'm also going to add the GraphQL related decorators here. And it's coming from this import of NestJS itself. So nothing extra you have to import outside of NestJS. So it's a part of NestJS. And if you specify it as field, it will mark it as a field of GraphQL schema as well. And of course, object. So everything is present in the documentation. We wouldn't go into that in this presentation, because otherwise it'll become really long. But all you need to know is, as soon as you add these decorators and save this particular file and register it with the modules. So if you see the modules here, post module, common module. Yeah, so you've added these, do some sort of configuration. It's very well mentioned in the documentation. And then link this, of course, common module with the final module. So NestJS knows that these are the modules, and that it knows what it needs to generate. And eventually it will create this schema for you. So you see, there's a type of comment, which has an ID. An exclamation mark at the end means that it's a required field. And then a title and the post. And these posts and these things are linked like this. So you don't have to worry about GraphQL much. You just have to learn NestJS and it will take care of all these things for you by itself. So yeah, we have generated tables inside the database, and we have also generated our GraphQL schema. Now, what's next? Let me move to the presentation again. So yeah, this is what I was discussing. So let's look at this example of, again, so there's a post. I think we already discussed it in the code example. And then it'll generate the schema for you by itself translating it to these queries and, executing in the database. Just we saw in Postigo right now. And again, to move it to the next level, so we added GraphQL related decorators, which generated the GraphQL schema for us. Now, so right now we have just generated the schema. We have just generated the typings. So we know that, okay, there's a type of comment, there's a type of post, and post is linked to comments in the way that it can have multiple comments inside it. Yeah. And then eventually what we need out of all this is we want to have our CRUD APIs, right? So in GraphQL, the read operation is a query. So because we are reading the things, and as you remember from the example of weather API that we discussed, so read API means that we are not just reading it, but also querying it in the way we want. So wherein we specify the fields that we want. And so that's what a query means. So what kind of queries we can have? So we can have a query for getting all of the posts. We can have a query for getting just one post with a given ID. And then again, same thing for the comments and for getting one comment in its individual isolation. And then, so that's about the read operation, but what about the create, update, and delete? So all of those come under mutation. So you can see the kind of mutations I have here. So I have a create post mutation, and I have an update post mutation, remove post, add a comment, create comment, update comment, remove comment. You get the point. So everything besides read comes under a mutation. So these are the two things in GraphQL. There's also a third thing. It's called a subscription, which is very useful for things like when you want to use WebSockets. So wherein you want hot updates. If, let's say, a comment comes on a post, at any given point of time, I should receive a notification, or my UI should get updated instantly. So that's another GraphQL operation, but we're not going to capture that here at the moment. But that's also possible very easily in NestJS realm. So, and then again, these are the queries. Everything here is generated by NestJS. We just have to write the classes, and it'll automatically generate it. So let's look at how we write the queries and mutations inside these files. So these come under these things called as resolvers. Comment.resolve is just a naming convention, that's all. And let's look at the comment resolver first. So you can see it has everything from related to CRUD. So there's a mutation which says create comment input, and then there's a query named comments, which will receive all of the comments for a given post ID. Perhaps it will get a complex. Let's look at the post resolver because it'll be easier to understand. So let's look at the query which fetches all of the posts. So this is a simple one. So I've decorated this method name called as find all, and this will be translated to a query called as post, and the return type is an array of post types, which that's a class we had created earlier here, right? And this is nothing but an abstraction for retrieving it from the database using NestJS, and it'll fetch all of the posts from the database. That's all. Similarly, if you want to find one, you'll need to get an argument named ID, and its data type should be string. And yeah, so you're going to use this operation of type ORM NestJS to get that. So irrespective of what's there inside the body, we just need to focus on this one. You can very well, for this demonstration purpose, hold a blank array and try to populate it. But this is what we are more interested in at the moment. So we are decorating our functions with these decorators as query or mutation, and internally you can have all your business logic inside it as per you want. So similarly for update and remove post delete operation, you have all of these things. Now, eventually these will get translated, as I showed you, to these. things. So when you needed an argument, it'll get translated in this format. So this is the GraphQL API. This is the specification of GraphQL, how you should have. So you don't have to worry about it. It'll get generated for you. And then, so that's our backend. Our backend is done, right? And yeah, so that's what we discussed right now. An example of GraphQL queries and GraphQL mutations. And create post mutation. And yes, so you have to configure your GraphQL NestJS application inside. Again, all of this is present in the documentation. You can very well go there and learn this. So inside my app.module.ts, where I had configured my database, I've also configured another thing, telling NestJS to auto-generate my schema file in this path right here. So I've generated my schema outside this folder server, so I can consume it in the client later on. And that's how it's being outputted here, right? Yeah, so this is the schema that's getting generated. Now, before we move to front end, are there any questions we can take right now? I know it's a lot to take in. I have a GitHub repository, and I'll paste the links, of course, share this presentation with you as well. But are there any glaring questions we can take right now?
Yeah, we do have a few questions, Varun. Just let me. Okay, so one of the question is, can you give us an example of how to integrate automatically generated TypeScript types into React.js components using Apollo client? Yeah.
Yes, we'll come to the front end part just in a moment. Right now, we've just discussed about the backend side of things. But yeah, we'll come to that, the TypeScript side of things as well in a moment.
Okay. Are there any best practices to keep in mind when structuring GraphQL resolve in types to maximize the benefit of automatic schema generation?
There's no best practice. It's just the API that you need to follow. So yeah, the best practice. So the best part of using a framework like NestJS is that it's opinionated. So you can't deviate from the approach that's mentioned here. So that's the difference between a framework and a library. So that's exactly the difference between Angular versus React. That's my favorite question to answer. So Angular is a framework, React is just a library. So when opinionated framework is there, it wouldn't let you use any deviations from the norm. So you are already following the best practices by just using a framework in the first place.
And one more question. I think this is the last question. So how does automating code generation help in reducing errors and ensuring TypeScript safety while working with GraphQL and queries and mutation in React.js?
Yes, good question. So as you can see already, we have been creating classes here, and this is nothing but a TypeScript file itself. So this is already very much type safe. We are telling what kind of input a certain argument is going to be, and we know what is the return type a given mutation is going to be. So when you use the code first approach, so this is a code first approach, we are writing the code first and everything else gets generated from it. So that reduces or that eliminates, the manual error by itself in the first place. But yes, one can argue if I'm making an error here, then that'll still introduce an error, but of course that's up to the discretion of the developer then. But we have drastically reduced the manual errors by generating the schema instead of manually writing the schema ourselves. And there would be cases wherein the backend technology wouldn't be using TypeScript, right? This is an ideal workflow one might want, but of course the backend might be in Java, and the backend might be in some other languages. But again, for all the languages, we have these GraphQL plugins, and they can generate, for sure, GraphQL schemas by themselves. But as front-end developers, we'll be able to consume those GraphQL schema, and there'll be no confusion regarding, okay, you changed this, you changed that. I don't know what your API is returning. It was supposed to return a Boolean, it's returning a number. So those kind of things will get eliminated for sure. And we'll see how we can take it a next step further by using the GraphQL schema on the front end and the client side, and we'll generate the TypeScript code, not only TypeScript, but also ReactJS code out of it. So that'll definitely, reduce a lot of errors and synchronize your backend and front end together.
Yeah, I think that was the last question. I think we can continue with the presentation.
Sure. All right. Thanks. So yeah, that's about the backend. Now let's move to the front end part. So I'm using NestJS. I was just being experimental. I haven't used NestJS much, but again, it's nothing but a little framework again on top of our library, on top of React, which adds a little more structure and protects you from a lot of things. But anyway, let's discuss about how we can use the schema that we generated in the last step to generate the code out of it. So what we want to generate eventually is we want to generate some hooks, which will say use get posts or use get comments, or something like use create post, use update post, or any of these into a hooks kind of format. So how good it will be if we are able to just get that, and eventually on our front end code, all we need is to use those hooks and, call those hooks on certain user events like button click or keyboard events. So for that, irrespective of your choice of ReactJS framework, you can write this codegen.yml kind of file. You need to specify where your schema lies, GraphQL schema. And in case it is hosted on a URL, you can also provide a remote URL here. But in our case, it's locally located. So I've just given it a URL of my local place that I have it in. And then you need to tell where do you want to output it. So I want to output it in this pages folder inside. This is not the output. This is another side of things I'll tell you about in a moment. This is the output, SRC generated GraphQL.tsx. So inside generated folder, this is the output of all this code generation that we'll touch upon in a moment. So all the hooks I was telling you about, get posts query, get posts lazy query, create post mutation, etc. All of these will be generated using this script and a bunch of commands. And then you're telling what kind of plugins you want. So you want it to generate it in the TypeScript format, and then you want to use React Apollo. There are plenty of these plugins that you can use for your purpose. And then you can also tell them, okay, I don't want to use it. I don't want to generate HOCs, high order components. I want to use hooks, and it'll generate hooks for you. And so basically, these are a lot of configurations that you can use. And then I think I was just experimenting with these, but this is what you need as a schema file generation configuration. And all you have to do is in your package JSON, you have to create a command, or you can run directly in your terminal called as GraphQL codegen. And it'll look for the codegen.yml file in your root of the project and generate the things at the output folder under that name. It'll generate all the things for you. So that's how you generate it on the front end. Now, before generation, we missed on one step. So that step is that, remember we told, so if I move back to this slide about pruning the data, about data pruning. So we want to tell the query that we are receiving, we want to tell the backend that these are the fields that I want from it. So for example, for showing all of the posts for a given route, where is it? So this is my home page. So in this page, I want to show all of the information. I want to show the title of the post. So, okay, this is the data. I'm sorry, my Zoom. So this is the data that I'm receiving. ID, title, and then comments. And inside a certain comment as well, I'm receiving the ID and the title. Now, let's say a requirement came and your product manager says that we just want to show the titles of the posts. We don't want to show the comments right away. It's only when the user presses on goes to a given post, we should only see the comments then. So for that, for all of this requirement, you can write a GraphQL query telling them that I just need the titles. I don't need the comments. So all of that you can create, you can specify in certain file, which is, you need to create a certain file. I've created this file called as post.gql. And this is where I'm telling the kind of queries I want. This is the name of the function that will get generated. And this is the thing that we are more interested in. So we want to look at the posts query. If I open the schema for you right now, so there's the query called as post, which is returning us with an array of post entities. And out of those posts, when we get those posts, I'm asking it to receive ID and a title and comments. And then for each comment, I want to receive its ID and a title. Now, if I want to change it, let's say I want to create another version which says, another query which says, get posts without comments. And here I eliminate the comments, and it'll basically go to the same endpoint, but retrieve the data in the way that you want, in a pruned way. So that's like another variant of this. Now, once I save this, I need to regenerate my generated files, and I will cd, okay, this is yarn generate or GraphQL code gen. That's a command that's going to run, and it automatically will generate these under the folder I'd specified. See this? So the modified part is here. You see, use get post without comments query, and it'll give you a response, get post without comment document, and this is how it looks. So it just gives you the ID and the title. So by the way, if you want to explore your schema, there are very nice tools about it. So the first one is, of course, the GraphQL Playground. I forgot to share this. So when you run your NestJS application, so this is where your NestJS application is running, 3001, of course, there's no get URL, but you do GraphQL / you can control this in the configuration itself if you want this or not. So you can, it's like a postman for GraphQL. There are very good other tools using the Apollo Playground, but that is like a paid sort of freemium sort of version, but that's really good as well. So yeah, coming back to our front end. So we were discussing about how data pruning and how easy it is to generate the queries and mutations, the kind of queries and mutations you need for your UI. For example, you need this for your home page, and then there's another page which says get posts with comments, and you can run that query over there. So let's look at how you can bind it on your pages now. So there's a page I have here called index.tsx, very simply. And let me fold all. So this is my home page. And here I have my JSX looking like this. Okay, I shouldn't have folded everything. So this is my JSX. It's nothing but a container which is showing me, the post, and there's a input form here. And let's look at this thing right here. So how am I getting the post data dot post, and I'm trying to map it? It's a very common pattern, right? So all I have to do is where is the post query? Yes. So this is the post query that I have. That's all I have to do in order to fetch posts from my backend. So I'm using this already generated use get post lazy query. Why is it lazy? Because if you don't use the lazy format, it will start getting the posts as soon as the component mounts or something else. So eventually that's what I'm doing, but there's some subtle difference based on that. So get a function called as get posts, and you need to call that get post function whenever your component mounts, as I'm doing here. And then in the second argument, you get all of the data that, okay, is the query loading? Is there an error? Is there a post whenever the data is available? So that's what you can use, these things inside your JSX to tell, okay, whenever the posts are available, just render this. And that's it. If you want to show a loader, the loading flag is also there. If you want to show an error, the error flag is also there. So you can see how simple it is to fetch data. Now that's about fetching. Let's look at a mutation. So there's a mutation which is use create post mutation, and it's nothing but a function, which you can again call on a form submit event, ABC, create post. And yeah, if you see the payload, it's sending all of the data in it. Sorry, this is a mutation. That was a get call. So this is the data, and you can see the data that I passed, the title of ABC is passed in something called as variables. So this is a GraphQL schema, basically, a GraphQL specification that you need to follow and understand. And that's all. All you have to do is call a function which is generated for you, pass it the parameters in the way it wants, and that's it. And then you follow it with other operations like get posts again. You can call this function again once it loads, so that it loads the newly generated thing again. And same thing goes for your remove. Okay. I know I created the remove one. Something happened in GitHub, but you get the point. So you can create all of these CRUD operations. So everything is present inside the generated folder. Whatever queries and mutations you specify in your GraphQL file here, it'll get generated in your generated file by the virtue of that command, GraphQL code gen that I showed you. So all of these operations are present here, and you can use it in your components wherever you want throughout your application. So let me see if that's what we wanted to discuss. Yeah, so that's all for the front-end binding and the back-end creation of the GraphQL APIs. I think we can take the questions now. Yeah.
Yes, I think we have a question, Varun. So the question is, are there any performance consideration while using automated schema generation, especially in scenarios where the schema might become extensive?
Yes. So the downside of using auto generation is that you can only control it to at a given extent, right? So you can't have full control, definitely. But as I said, there are plenty of plugins while generating the GraphQL schema, because this thing has been there for quite long. So this code.yaml file I used here. So I was using it for a React Native application, this thing. And as you can see, you can strip down, for example, on certain comments. There are plenty of plugins like that. So using the set of configuration that will suit your needs will help you in achieving the desired results that you want. So yeah, but that said, I haven't faced much problem. And also these generators are developed using the best practices in the industry. So that's another thing as well. If you probably do it by yourself without learning the entire thing, as front-end engineers, you might rather get in trouble in that sense. But again, if you have very strict requirement about a certain requirement which is not fulfilled by the plugins, then you can use the other approach. So this was the code first approach, by the way, that we discussed. There's another approach which is the other way around. So you can write the GraphQL schema by yourself, and it will generate the NestJS files for you. So that's also possible, but it wouldn't be possible in the ReactJS world. Probably there's some library or plugin that does that, but I'm not aware of it. But yeah, in my experience, it generates a good quality schema, with comments and everything. So there are plugins which will, reduce the comments or, change the casing. If you want hooks, you can use hooks, or if you want HOCs, you can use HOCs as well. So yeah, it's very highly configurable eventually. Mm-hmm.
We have a question in the chat, and that's from Manu. And the question is, what is the major difference between using APIs, the REST API and the one from GraphQL?
So the difference we discussed, right? The REST APIs, the difference is that the difference is in the way these APIs are being called. Eventually, the operations are the same, the CRUD operations, but as I mentioned, there's just one single endpoint, as you can see, in GraphQL world. So all of the endpoints, so this was a get post endpoint, but still it is a post. This was a post endpoint for creating the post. It's still a post. And again, the same get post. So the endpoint is one, but the operations might be different. The payload would be different. So we are telling it what operation name is it, and is that a query or is that a mutation? So that's how it differs. And also, of course, fundamentally how GraphQL is different from REST APIs. We discuss the challenges faced with REST API in terms of data pruning and eager loading, etc. So yeah, that's how they are different.
So we have one question, and that is, as projects scale, they might be shared components across multiple teams. How can automated schema and TypeScript generation facilitate collaboration and maintain consistency in such scenarios?
Yes. So when we have different sort of different repositories, yes, it becomes difficult. So practically speaking, I faced a similar kind of problem because the schema that was generated by the backend guy in Node.js, it was on a separate repository, and I didn't have access to the schema.graphql. So what the backend developer had to do, he had to upload it to a given endpoint, and then inside my codegen.yaml, as I said, instead of specifying the local path here, I would specify an HTTPS, blah, 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 somewhere on AWS, wherever it's hosted. So you can do that. And then again, so if you have different repositories for front end, what you can do is, so that's the beauty of the GraphQL schema code generation. So you have the schema file located at a certain hosted at a certain endpoint. And then that will be accessible to all of the people in the front-end teams, across the front-end teams. And they can very well do a code generation based on their requirements using here. So everybody of those teams will have this code generation file, and they can very well use it. And yet, if you want to reduce those kind of scenarios wherein the person forgot to update the schema, the backend person forgot to update the schema, so you can run some sort of script. You can watch the contents of the GraphQL schema file and then run a job of updating it to a given endpoint and then notifying people on Slack, I don't know. So all of those things can be done, but that is more like an ops sort of thing. But yeah, for a large team, I think that those measures are there in place to handle those things.
Okay, I think we have one last question, Param. And how does NestJS and its code generation approach adapt to these to the changes, ensure compatibility? Yeah.
I didn't get that. Is there a place I can see the comments?
Have it from one of the, when we rolled out the polls, like the registration form. So we had one of the questions from here. Yeah. As GraphQL evolves and the features are introduced, how does NestJS and its code
adapt to these changes to ensure compatibility? So that is very much up to the library adopters, right? So as I said, the GraphQL support is right there inside NestJS framework itself, and NestJS is one of the very popular frameworks out there. So definitely the support is immense. So if you see here, fundamentals, techniques, GraphQL, there is a section about, so the GraphQL module, it's, oh yeah, here it is. So the GraphQL module is like inbuilt into this framework. So which means it is a huge part of this project, this framework itself. So the support is there inbuilt. And then the question is about how does NestJS and its code generation approach adapt to these changes and ensure compatibility? Yes. So we are using open source technologies, and we have to rely on the framework that we are using. And in my experience, they have been very active. They have a very good community around it on Stack Overflow and everywhere else. There was an error I was facing in type ORM, I still remember, but a lot of people had even posted about the alternatives for that. So it is a very popular framework and it is very well maintained. So we wouldn't come into those kind of situations. And also it at least, provides us with the very basic infrastructure, the day-to-day infrastructure. If there's something very cutting edge in GraphQL and that's what you want to consume. So yeah, that is another discussion. But in terms of day-to-day apps, it's very feasible to have this. It's a maintained framework end of the day. So yeah, that's good.
We have one question from the live of LinkedIn. So it is GraphQL lighter in operation than REST? I mean, it takes less network requests, the question mark. Yeah.
So yes, it is a lighter operation in the sense that when we see the response, we are just getting what we need. So we are just getting what we need. As I showed you in the example, if I don't want to load the comments, I will just tell the GraphQL file in my front end to not generate it. So we created two versions here. So one for getting posts with comments and getting posts without comments. So in that sense, it would be very light. So this is a very contrived example for the purpose of a demonstration. But as your app grows and in real production apps, this might become very a turning point, wherein you want to save the data in the response bodies. And I'm not sure what it means by does it take less network request? I think so in terms of response bodies, it'll take less space, of course, because of the data pruning that we have added here. So yeah.
Yeah, I think that's pretty much. Guys, please ensure that you're posting your questions as soon, because I think we're almost done with the presentation and we've taken up the questions. So if you have any last minute questions, please post that. So we'll be taking 1-2 questions more, or else I think we're mostly done. Okay, I think that was the last question. Well, and that brings to the end of this wonderful session. And I would like to thank each one of you for joining us on weekend. And well, that really shows your enthusiasm for learning. And we really, really love to have an audience like that who is, having a zest for learning, and that motivates us to bring amazing speakers like Param today. Right. And hope you learned something new from today's session. And we would look forward for your post on LinkedIn and tag Param along with your key learnings and takeaways. And don't forget to tag Greco and me, so that we would get more exciting speakers and amazing speakers like Param. And also thank you so much, Param, for joining us. And it was awesome having you. Thank you for taking out time and giving us such an amazing and insightful presentation. We had the great time listening to it. So yeah.
Thank you. Same here. Thank you. Thank you so much. Please reach out to LinkedIn if you have any questions. I've added the link of the slides on both LinkedIn chat and the Zoom chat. Yeah. Thank you. Thank you, everyone.
Yeah. Before we end the session, I have a few announcements to make. So we have created a community for developers called Rebase on Discord. So join a close community for developers. This is exclusively only for the people of 1+ years of experience. So if you're someone with 1+ years of experience, you can get a chance to connect with fellow developers, get career opportunities, ask for help, and get a personal mentor. So do join the link of the community, and that would be in the chat. And for the live people who are joining us live, I've dropped that in the chat over there. So you can go ahead and fill the form and join our Discord community, and you can say hi, and then we can help you escalate your professional career. So yeah, and we do not forget to share a LinkedIn post tagging Param, and also let us know what are your key takeaways, what's something that you love about the session, what's something that you learned something new from the session. And we would love to see that post, and do comment your learnings in this LinkedIn chat, and we would love to see that too. Yeah. And if you have more questions, you can follow Param. And I think his LinkedIn was given on the screen, or if you can, you'll also find Param on LinkedIn. He's very active and he'd be more than happy to help you guys if you reach out for anything, be it the presentation today or anything in general that you would love to know more about from his expertise, because he has an expertise in front end. So do reach out to him if you need any help, and he'll be more than happy to help you guys. And if you're exploring career opportunities, Recro is hiring passionate developers. Check out the current openings at Recro on recro.io/careers. And if you or your friend or your colleague or your family member is exploring for some opportunities, we'll make sure that we'll place them in the A-grade startups of the country. And to stay updated with such events, follow us on social media. Follow us on Instagram, Twitter, LinkedIn, and YouTube. And the recording of this would be posted in the Discord community. So please ensure that you're a part of the Discord community if you want the recording. And the recording of this would also be out after a few weeks. But till then, you can actually have the access to the live recording. So if you missed anything in between, or if you want to recheck it again, or if you want to share it with your friends or colleagues, you can share the LinkedIn live, or you can also go to YouTube and visit Recro's page, and we'll also be live over there, so you can go check it over there. And that's all for today's session, guys. Thank you so much for joining us. Hope to see you in the next one, and let us know what topic that you want us to conduct a webinar on. And if you want something, if you want the second part of the same topic today, we'd be more than happy to get Param on the second version of this. And yeah, thank you so much, Param, again, for being a great speaker. And we had a great time listening to you, and thank you for all the learnings that you've given. Thank you so much. Thank you so much. Have a great weekend.
You too.